Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Today, students, we are going to start with our new chapter, that is Coordination Compound, under our batch, Excellence Batch. So, students, before proceeding to this particular session today, let me tell you one thing that you need to keep in your mind whenever you feel like demotivated. When you feel like giving up, don't quit. When you feel like giving up, don't quit. Look around and find blessings around. Keep going. When your problems seem overwhelming, don't quit. Take one step at a time and keep going. When you don't have answer, don't quit. When you don't have answer, don't quit. Talk to others and find the support. Keep going. When you are discouraged, don't quit. Don't give up, just keep going. So students, this word keep going really matters a lot when you are preparing for certain competitive examination. There is a particular time when students feel that, syllabus is more, time is less, and there is a huge pressure on them. But trust me, students, you just have to keep going on into the process. Just don't quit, don't sit down, and don't let your motivation down or your inner self-confidence down. No, not at all. Just believe in yourself and just keep going. And trust me, you will lead to a very beautiful path if you believe in yourself. Yes? So with this quote, we shall start our today's session. So as I told you, today we are going to start with our very fresh chapter, that is Coordination Compound, under our batch, Excellence Batch. So as you all know, our batch name itself says Excellence. That means we have to study and work really very hard in order to excel in our fields. Yes? So students, if I talk about this particular session today that we are going to do, it is based upon the lecture number first. Now in this particular session today, what shall be the topics that we are going to cover? See, first of all, we are going to see the introduction with regard to what is coordination compound. What are coordination compound, I would say. Okay. So the very first thing that we are going to do today is going to be introduction. Then after that, students, we are going to study about what are addition or molecular compounds. Basically, we are going to see what are addition or molecular compounds. And then we are going to classify them. We are going to observe they are further classified into double salts and the complex compounds, or in other words, I would say the coordination compounds. So we are going to see that from where does the coordination compound category arise, right? It arose, sorry. So if I talk over here, addition compounds, we are going to further look up to double salt topic as well as the complex compounds, or I would say the coordination compounds. Yes, okay. Now students, after this, what we are going to see? We are going to see the representation of the coordination compound, how we are going to represent a particular coordination compound or the coordination complex, right? So we are going to see the representation. Right. So basically in this particular session, we are also going to understand the main important terms with regard to the chapter coordination compounds, such as ligand. Ligand topic is really very important. We are going to see the classification of ligand based upon its denticity as well. So after the representation, we are going to see the important terms. And then students, we are going to study about ligands and its classification based upon the denticity. Okay? Based on denticity. I'll let you know what is denticity. But before that, let us start with our initial topic, that is introduction session. So if I talk about the introduction session, first of all, I will be giving you a particular compound and we shall be discussing some of the important key points in order to understand what is a coordination compound or how a coordination compound is being formed, right? So if I talk about a very simple example, a very general example that I am taking over here, it is K4FeCN6. So I have written a particular compound in front of you. Now I will be telling you what is K over here, what is Fe over here, what is Cn over here, what does the square bracket represent? Each of them holds a particular importance, right? So let me tell you first of all, students, if I talk about this particular square bracket, this is referred to as coordination sphere. Now understand the very basic things over here. This is a coordination compound. This is what? It is a coordination compound. No worries, students, I'm going to tell you the definition, but before that I want you all to at least look up to this particular compound and understand the very basic few things that you require in the upcoming segments, right? So if I talk about this particular compound, we shall be studying in representation again the things that I am telling you here. We shall be repeating it again, but see, if I talk about this particular sphere that I have, or I would say the square brackets over here, it represents coordination sphere. What does it represent? Ma'am, it represents coordination. It represents coordination sphere. Okay, or we can say the coordination entity. Now students, understand over here, after this we have Fe over here and we have 6 cyanide ions over here. That means Cn over here. Understand the two basic terms. One is referred to as central metal atom, another one is ligand. I am talking about two different terms. I am talking about a term that is central metal atom. Okay, and I'm talking about one more term, that is your ligand. What do you refer to both of them? See, central metal atom, as you can itself says, if you don't know the definition of them, you know what is the metal, you know what is an atom. Now what is central metal atom? The one which is present at the centermost position. Okay, this is just the English version of this, that I would say, that you can just look up to a particular term and you can say accordingly, right? But what is actually a central metal atom, or what are the characteristics in so that a compound, in order to be a central metal atom for a particular coordination compound, we shall be seeing that central metal atom over here, which is forming a coordination compound with particular ligands, it should have certain conditions. Now these certain conditions hold the vacant orbitals. Why the vacant orbitals? Because here I used the term ligand. Now what is the usage of ligand? Ligand basically donates its lone pair of electrons to the central metal atom. Now if central metal atom is itself not empty or not vacant, it will not accept electrons. Are you getting my point? The one which is already empty, or the one which has a space, that only will accept electrons. So the very first necessary condition in order to be an atom, to be a central metal atom, to form a coordinate bond in the coordination compound, over there it should have at least vacant orbital, or I would say the availability of the vacant orbital, the empty orbital, so that it can accept the lone pair of electron from whom? From ligand. So now you get my point. What is central metal atom? Though there are many conditions, I will let you know what are the other conditions required for a compound to be central metal atom in this particular segment, right? I will let you know. But if I talk about this particular compound, the central metal atom lies inside the coordination sphere. This is the very first thing that you need to observe over here. Now, if I am saying that central metal atom lies inside the coordination sphere, or this particular square brackets over here, then what is the central metal atom? Fe is the central metal atom. So, I am writing, as I've written this with white. So, this is basically your central metal atom. Now, as I've told you, what is the use of ligand? Ligand basically donates its lone pair of electrons to the central metal atom. That means Cn over here is ligand. Now let me tell you, let us take a general example over here, and if I say that this is my central metal atom, and let us say there are 4 ligands that are donating the lone pair of electrons to this central metal atom in such a way. We shall be drawing different structures in the upcoming segment, no need to worry about it. So basically this is the kind of a representation that you can understand. This is your central metal atom, and these ligands basically are donating the lone pair of electrons. So I have written this in this particular direction. The arrow in this particular direction. Is it clear? This is the general things which you should know over here. Now coming back to the topic over here again. Now you are able to identify what is this. This is the square bracket, or the coordination sphere, or the coordination entity. This is the central metal atom. This is your ligand. What does 6 represent over here? Now what does this 6 represent? This represent number of ligands. This represent number of ligands, that how many ligands are present. Basically here are 6 ligands present over here, so the sixth number is representing number of ligands. Okay ma'am, it's clear. Now we are able to identify what are the atoms that are present, or the compounds that are basically enclosed in this particular sphere. But what do you refer to as this K over here, potassium over here? What is the usage of that, ma'am? Kindly explain it. So basically students, what happened, this basically is our counter ions, or I would say the ionizable ions. Now understand this term also over here. Which color I have not used? Let me see. Okay, let us take one more color over here. So this is basically what it's your counter ion. It's your counter ion or ionizable ion. Counter ion or ionizable ion. Right? Now, ma'am, it's okay that you are referring it as counter ion. Okay, it would be a name. But what do you refer to as ionizable ion? Are you getting a term ionizable? That means which can ionize further. Okay, ionizable. Ma'am, then there shall be a word non-ionizable. Yes. If it is ionizable ion, the ones which are present inside the coordination sphere are the non-ionizable ions. See, the one which are present outside, whether it is present on this side or whether it is present on this side, but outside the coordination sphere are the ionizable ions, but the ones which are present inside over here really sorry, over here, these are non-ionizable ions. Are you getting my point, students? Is it clear to you? Great. Now these are the very basic things that you require over here, that you should know in order to understand what is a coordination compound. Now if I have to define a coordination compound, now coming back to this two things over here again, ligand has a tendency to donate its lone pair of electrons to the central metal atom. That means when I am talking about ligand and central metal atom, they shall be forming a coordinate bond. Which kind of bond? Coordinate bond. So a compound in which ligand donates its lone pair of electrons to the central metal atom in order to form a coordinate bond, those compounds are referred to as what? Those are referred to as coordination compound, right? So if I want to write the definition with regard to this, we can write those compounds in which ligand donates its lone pair of electron to the central metal atom, forming a coordinate bond is referred to as coordination compound. Is referred to as what? Is referred to as coordination compound. Is it clear? Students, kindly write this definition so that we can move on to our next part. We can start our chapter from here. Now I guess you all are aware what is a coordination compound, right? Shall we start, students, with our next part, that is addition compounds. So this ends our introduction session over here. Now if I talk about what is addition compounds, now I'm going to tell you from where does this category coordination compound was basically seen. Okay, now see, if I talk about addition compounds, these are basically those compounds in which we can say two or more simple salts are allowed to chemically combine together in a fixed proportion, and after crystallization we get what? We get addition compounds. So how are addition compounds formed? When two or more than two simple salts. Now simple salts is basically referred to as the one which contains one type of cation and one type of anion. Are you getting my point? When two or more than two simple salts are all together mixed together and then they're further crystallized, okay, in a fixed proportion by weight, we get addition compounds. Now addition compounds are further classified into double salts and the complex compounds. Complex compounds in other terms is referred to as coordination compounds. Are you getting my point? Now we shall write the definition for addition compound first of all and look up to the certain examples. So we can say when two or more than two simple salts are combined together are combined together in a fixed proportion by weight, further leading to further leading to crystallization, forms addition compounds or the molecular compounds. Addition compounds or molecular compounds or molecular compounds. Right? Now I will give you a particular example in order to understand. For example, students, we have KCl, we have MgCl2, okay? And then this is further mixed up in a particular proportion and then crystallized all together. We will get a compound that is addition compound. Now what we shall obtain over here? We shall obtain KCl dot MgCl2 dot 6H2O. This is the compound that we obtain after crystallization. Now what happens when we are mixing them all together? Right, when we are mixing them all together, I am again referring to over here simple salts are referred to those salts which contain one type of cation and one type of anion. So when they are mixed together in a fixed proportion and then further lead to crystallization, we shall obtain this particular compound. Similarly, you can see alum, potash alum, that is a compound that is obtained, that is referred to as addition compound, that also lies under this category. Okay, now students, moving on to the next part that I have already told you, that addition compounds are further classified addition compounds are further classified as double salt, and the second one is complex compounds or the coordination compounds. Okay, so addition compounds are further categorized into these two sub-basic categories, right? Okay, now students, moving on to what is double salt and what is complex compound or the coordination compound, we shall see in detail. Double salt are the one which don't lose their identity, and complex salts are the one which may lose their identity. First of all, I want you all to write it down so that we can just write about double salts and the complex compounds. I guess you have written this? Yes. You can even write one more example that I've told you about potash alum. Now coming back to this topic again, as I was telling you, these are the one which don't lose their identity. Now you might be thinking, they won't lose their identity in what, ma'am? When they're dissolved in aqueous solution, they won't lose their identity. So you can write over here, these are the ones which don't lose their identity, in aqueous solution. I'll let you know by giving certain examples, don't worry about it. But these are the ones which don't lose their identity, okay? Now, these are the ones which get completely ionized. That means they can completely split into their particular ions, okay? So you can write over there, these are the ones which get completely ionized. That means they can particularly split into their ions. One more thing, they always give positive test for their constituent ions, okay? They give they give positive test for ions, for their constituent ions. Now you will say, ma'am, you are letting us know these particular characteristics of double salt, but what are these? Kindly explain it. So as I've already told you, I will take a particular example, and with the help of that, I shall explain you all of them all over here again. They give positive test for their constituent ions. But till then, kindly write it down so that it will be easy for you to understand. Write these 3 points. Now I'm giving you a particular example that we have just done right now. See, the example that we took right now was KCl plus MgCl2 after crystallization was forming KCl dot MgCl2 dot 6H2O. Right? Now see students, understand this. What is happening over here? When they are dissolved in their aqueous solution, that means in water, what happens? They are forming this particular compound, which is addition compound, which on further when categorized is a double salt. How they are double salt? First of all, understand this thing. See, if I talk about this reactant over here, what are the particular types of, I would say, ions present? You will say, ma'am, K positive is present, ma'am, Cl negative is present, ma'am, Mg plus 2 is present. Yes, am I right? Over here K positive, Cl negative, over here Mg plus 2, Cl negative. Am I right? No. Okay, so when they are dissolved in water, what happens? What happens? I have already told you, these are the ones which don't lose their identity. That means initially if they were having K positive, Cl negative, Mg plus 2, then at final also they will be having the same ions. They will be having the same ions. They can be further split into their particular ions. For example, they can be further split into K positive, Cl negative and Mg plus 2. Yes, they can be split even after mixing in it with water. So that means they are not losing their identity. They retain their identity after this particular reaction also. Right? So we can always say that the properties of the compounds is just similar to the properties of the constituent ions that are present in between them. Right? Because they don't lose their identity. Also, if I talk about double salt, one more thing, they generally exist in solid form. Generally exist in solid form. Generally exist in solid form. Now, when you are going to understand about complex compound or the coordination compound, you'll automatically get what is double salt. While comparing both of them, you'll automatically get. Now, coming to the topic complex compounds or the coordination compounds, these are the ones which may lose their identity when they are dissolved in aqueous solution. So, we can say these are the ones. These are the ones which lose their identity when dissolved in aqueous solution. Okay, they lose their identity when they are dissolved in aqueous solution. Now, other than this, they don't get 100% ionized. In the previous session, you have seen in this not previous session, in the previous topic, as I've told you, they can further be ionized properly into K positive, Cl negative, Mg plus 2. But these are the ones which do not get completely ionized. Okay, so these are the ones which don't get completely ionized. See, now you can correlate with the introduction topic of the coordination compound. I gave you a certain example. The example was K4 FeCN6. I told you over here, this K over here is the ionizable one. That means it can be further, split into K positive. When it is put into aqueous solution, K positive can be separated. But this whole thing is non-ionizable. The one which is present inside the coordination sphere are the non-ionizable ions. That means Fe over here cannot be separated out. Cn over here cannot be separated out individually. In this particular double salt topic, I have already told you this K positive can be separated, Cl negative can be separated, Mg plus 2 can be separated. But over here, students, this does not happen in this case. What happens in this case? Only this and this particular will separate. Let me tell you how. See, when I am going to dissociate them, K positive will be separated out. How many K are there? 4. So 4 K positive will be separated, and this complex remains as it is. Now if it holds +1 charge and 4k positive overall +4 charge, it will hold -4 charge. What is happening? Only k positive is being ionized, it is being separated, but this particular remains same because it is non-ionizable one. But if you talk about double salt, it can be further categorized into K positive, Cl negative, Mg+2 further, but they cannot be. They are not completely ionized. Is it clear to you? Now they can exist as solid as well as aqueous form or the aqueous solution. Okay, they can exist in both the forms. And over here, the properties of the particular ions are different to the properties of the complex. But in the previous case, the properties were same when I'm talking about compound or its particular constituents. Is that clear? So from here, the coordination compound topic was started. Is that clear to you, students? Now, just I have dissociated them. How I have dissociated, you can clearly see, you know that K has a +1 charge, potassium has a +1 charge. How many? There are 4. So it will be 4 written in front of it in order to balance it out. And this particular will get separated out because it is a complex. Now if it holds +1 charge and total 4 are there, +4 charge, it will hold how many charge? Because see, it is a neutral molecule. When there is no charge, that means there is equal positive and negative charge. So over here, if it is +4 charge, it will hold -4 charge over here. Is it clear to you? Yes. Okay, students, now we shall start with the next topic of ours, that is the representation. That is what it is, representation. Now I've already given you a particular example, just we need to write the terms for them, right? So kindly write this. First of all, I'm going to tell you what is A, what is B, what is M, what is L, what is X, what is N. First of all, write it down. Now write one by one. What are A and B? A and B are counter ions or ionizable ions. Counter ions or ionizable ions, right? Okay. What is M over here? M is central metal atom. What is M? M is central metal atom. Clear? Okay. What is L? L is ligand. What is L? L is ligand, the one which donates its electron to the central metal atom. Okay. What is X? X over here is number of ligands. What is X? X is number of ligands. Then what is N over here? N is the overall charge of the coordination sphere. Overall charge of coordination sphere. So I have already told you all the terms. Let me repeat it to you once again. I have already told you whether over here the atom is present or here, they both will be referred to as counter ions or the ionizable ones. M is the central metal atom, L is the ligand, X represents number of ligands, N is the charge. It can be positive, it can be negative. So plus and positive and negative sign both are written over here. Now we shall study about one by one. I have already told you their role. What are their importance? From NCERT we are going to see about them. We are going to read them from NCERT. Right? Now these are the lines which I have taken from NCERT, which I shall be reading one by one. First of all comes coordination entity, or I would say the coordination sphere. Let me tell you what it is basically. A coordination entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules. Now this fixed number of ions and molecules are the ligands that they're talking about. Okay. So basically they're saying a coordination entity contains what? A central metal atom which is bonded to whom? Which is bonded to a fixed number of ions or molecules that are your ligands, right? Example they have given you over here. I'm writing the example. It is CO, Cl3, NH3, thrice. What is a coordination entity? This is which is central metal atom holding 3 chlorine and 3 NH3 over here, bonded to a fixed number of ligands. Great. Is a coordination entity in which cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. Yes. Okay. Other example they have given you over here. If you see, nickel is surrounded by 4 CO molecules. Over here if you see, platinum PT is surrounded by 2 chlorine and 2 ammonia molecules. In the next one, if you see, Fe is surrounded by 6 CN, right? cyanide ones. Over here again, cobalt is surrounded by 6 ammonia molecules. This -4 is the overall charge on the sphere. This +3 is the overall charge. Not written aside. It is the overall charge. So I guess this is now clear from the NCERT section. Now let us see the second term from the NCERT, that is about central atom or the ion. The central metal atom. Okay. In a coordination entity, the atom ion to which a fixed number of groups are bound in a definite geometry arrangement around is called the central metal atom or the ion. Right, to which ligands are bonded basically. For example, the central metal atom in the coordination entities, if we talk about this particular compound over here, nickel is the central metal atom. If I talk about this particular, over here cobalt is the central metal atom, over here iron is the central metal atom that they have written, right? So these central metal atom are also referred to as Lewis acid. Why? Because they are accepting lone pair of electrons from the ligands. Right. Shall we proceed to the next NCERT lines? Right. So in the next topic in the NCERT is about ligands, which we have already studied. I will let you know what they are saying. The ions of molecules bonded to the central metal atom in a coordination entity are called ligands. The one which are bonded to the central metal atom. They may be simple ions. They can be simple. For example, Cl negative. Small molecules such as water or ammonia, and even larger molecules such as they have given you. Now, I will be giving this particular example when we are talking about in the classification of ligands. Ethylene diamine, EN, okay, oxalate, we shall be studying. The complex ones are also the ligands. So, we shall be seeing the complex ones, okay, or even macromolecules are also ligands or proteins, okay, such as proteins. Now, coming to the next topic, that is the coordination sphere. Coordination sphere, the square bracket, okay. Central metal atom and the ligands attached to it are enclosed in square brackets and is collectively termed as what? Coordination sphere. It is collectively termed as that. The ionizable groups are written outside the bracket, already told you, and are referred to as what? Counter ions. For example, in the complex, in this particular complex, if we talk about the coordination sphere is this one, and the counter ions are the K positive that are present outside the sphere. Is it clear? Is it clear to you all? Great. Now moving on to the next part, which I have to tell you just right now. I'll let you know. Oxidation number. See, oxidation number, first of all, let me make you understand. Oxidation number, students, in other term is referred to as the formal charge on any atom or on any species, I would say. The individual charge that is present on any atom is referred to as oxidation number. So see, we will be calculating oxidation number for the central metal atom in the upcoming segments as well. When you're going to do the naming as well, I will let you know how to do that. Okay, so don't worry about it. Just understand first of all the basic important terms with respect to this chapter. The oxidation number of the central metal atom is complex and is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central metal atom. They are just letting you know how you have to calculate it. Don't worry, we shall be discussing in the next lecture how to calculate it. Okay. The oxidation number is represented by Roman numeral in the parentheses following in the name of the coordination entity. While naming, I'll let you know how to do that. Okay. Now moving on to the homoleptic and the heteroleptic complexes. See, complexes in which a metal is bonded to only one kind of donor groups. Now what is the role of ligand? That it donates electrons. So if it is only one kind of donor group, that is homoleptic. Example, over here you can see ammonia. In ammonia, you can see that basically nitrogen is the one which is donating ammonia. That means one kind of ligand is present, so it is homoleptic complex. But a complex in which a metal is bonded to more than one kind of donor atom, right? More than one kind of donor groups, the one which donates. Example, see, over here 4 ammonia are there and 2 chlorine are there. That means over here ammonia is also the donor atom as well as chlorine is also the donor atom. 4 ammonia are in which nitrogen is donating and chlorine in which chlorine is donating. 2 chlorines are donating. So there are 2 different kinds of donor groups. That means it is heteroleptic, and in the one only there is over here is ammonia which is donating, so it is homoleptic, in which only one kind of donor group is there. So these are the basic terms that you need to know from a NCERT. I want you all to kindly read it. I am giving you just a minute so that you can do it, and we can proceed to our next topic now. Kindly do this, my dear students, so that we can proceed to the next part. Now the next topic comes out to be coordination complex. What is the next topic? It is coordination complex. Before moving on to the types of ligands, we shall do the types of coordination complex or the coordination sphere, I would say. Okay. So coordination complex. So coordination complex is further categorized into anionic complex, cationic complex and neutral complex. Anionic complex, cationic complex and the neutral complex. Okay. Now, see, if I say that the coordination sphere holds a positive charge, that will be my cationic complex. If the coordination spheres holds an overall charge of negative sign, it is anionic complex. And if it does not hold any charge, it is a neutral complex. Okay. So you can write if coordination sphere or the coordination entity holds overall negative charge, it is anionic complex. It is which complex? Anionic complex. Giving you a particular example such as Ag bonded with 2Cn holds a -1 charge over here. Okay. So overall, what charge? A negative charge, so it is an ionic complex. Now in the case of cationic, if it holds overall which charge? A positive charge. Which charge? A positive charge. That is your cationic complex. Is it clear to you? Now giving you a particular example, CO bonded with 6 ammonia holds +3 charge. Now overall here, what is the charge? +3, positive charge, so cationic complex. And in the case of neutral, when there is no charge on that particular, that is referred to as your neutral complex. Is it clear? You can take the certain examples over here also. Now students, moving on to the next part, what are the conditions for an atom to be a central metal atom? Conditions to be central metal atom which will bond with ligand, right? Central metal atom. What are the basic conditions, students? This we have to see now. So the very first condition I've already told you, it should have vacant orbital. Generally it's vacant d orbital that we talk about. Okay. Other than this, the size should be small. The central metal atom should have small size, right? The next thing that you can talk about over here is nuclear charge should be high. I'm using this sign for high. Nuclear charge should be high. Also, the ionization energy should be high. Okay, so these are the necessity conditions for an atom to be a central metal atom in order to form a coordination compound. Is it clear? Kindly write 4 of these basic necessities. Now we shall move on to the next part, that is types of ligand. Now ligand, today we are going to do the classification based upon the density. So you can write over there classification based on denticity. Denticity. What is denticity? First of all, what is denticity? The denticity is number of donor atoms present over there in a particular ligand which are donating the lone pair of electrons in order to form a complex compound, right? So if I talk on the basis of denticity, the very first that we shall be talking about will be monodentate. Monodentate are the one in which only one donor atom is present. Okay. Ligands in which only one donor atom or one donor site is there, is present, is referred to as monodentate. Mono referred to as single, dentate refers to as the donor atoms, right? Example, if I talk about, is ammonia. In case of ammonia, students, nitrogen is the one which has lone pair of electrons and has the tendency to donate its lone pair of electrons to the central metal atom. So only one atom is present in this particular molecule. So this ligand is referred to as monodentate ligand. Other than this, if I talk about water, in the case of water, oxygen though has two lone pair of electrons, but the atom is only single, no? Oxygen is only donating. So when there is only one donor atom, oxygen is the donor atom, then it is referred to as monodentate. Other than this, you can say Cl negative, Br negative, I negative, F negative. See, negative sign also represents electrons, two electrons. That means it has a tendency to donate electrons. So Cl negative, Br negative, I negative, OH negative. All of these basically, students, comes under the category of what? Monodentate ligand. Is it clear? Is it clear? Now the next category comes out to be bidentate ligand. B is bidentate ligand. Now the name itself says when there are two donor atoms present, okay? The ligands in which two donor atoms are present. Ligands in which two donor atoms are present are referred to as bidentate ligand. Now the most important one is ethylene diamine. I guess this you have written. Kindly pause the video and write it down. Now I will be giving you a certain example, that is ethylene. It is generally represented as En. First of all, in many books you will directly see it is written as En. Okay. Other than this, you can also say ethylene diamine. Okay. Now what is ethylene diamine? Basically it is, see, ethylene, that means it is basically two carbons. It is how many carbons? Two carbons. Okay. One second. Also looking up to the valency of carbon over here, right? Carbon can form four bonds, no? So it is forming two bonds with hydrogen, one over here, one over here. So this is the structure of ethylene diamine. This is the structure of ethylene diamine. Now see, let us say this is the central metal atom. In ethylene diamine, we have nitrogen over here that is donating its lone pair of electrons. We have nitrogen over here that is donating its lone pair of electron. That means over here, this nitrogen can donate and this nitrogen can donate. That means in this particular ligand, there are two donor sites that are donating its lone pair of electrons to the central metal atom. So it is referred to as what? Bidentate ligand. Students, there is one more term, that is coordination number. I shall be telling you coordination number topic in the next lecture. First of all, I want you all to first understand and learn how to draw these structures, because without knowing these structures you cannot identify them and you cannot move on to the for the next topic. So my recommendation for you is to, when I am explaining you this particular topic, draw with your hands by your own. Just do not take screenshots of the topic, just write it by your own. If you are writing by your own, this will help you. This will automatically help you. Okay, so this is ethylene diamine, which is a bidentate ligand. Other than this, the next comes oxalate. Next example is oxalate. All the examples in bidentate ligand are really very important. Next is oxalate. Oxalate is C2O4 minus 2. What is oxalate? It is C2O4 minus 2. It is also represented as OX minus 2. It is also represented like this. Now how to draw C2? O4 minus 2. So see, minus 2, it is minus 1 charge, minus 1, minus 1 charge. How many donor sites are there? Two donor sites. See, if I say there is central metal atom, this oxygen is donating, this oxygen is donating. Two donor sites, so it is bidentate ligand. Kindly write it down. Kindly write it down. Now comes next example, that is glycinato. Next example is glycinato, represented by GLY. Okay, you can see it is as GLY. It is glycinato. Now what is glycinato, ma'am? Kindly explain. See, if I talk about oxalate, really sorry, just put a line over here. Take one of the following as same, like this, C double bond O negative, and replace the other one with what? CH2NH2. This is the structure for glycine-NATO. Over here again, two donor sites. One is nitrogen having lone pair of electron. Another one is this oxygen donating its negative charge electrons. Is it clear? Over here, this is the structure of whom? Glycine-NATO. This is the structure of whom? Glycine-NATO. Kindly write it down. Kindly write it down. Shall we proceed to the next part? Okay. Now comes acetyl acenato. Next is acetyl acetonato, also written as ACAC. And one more thing, there is a benzyl acetonato. This is acetyl acetonato. One more example is benzyl acetonato. This is written as BCAC. This is ACAC. Okay. Now, how to write it down? This is very simple. See, carbon. See, first of all, oxygen, carbon, CH, carbon, oxygen. Now, what you have to do? See, you have to make alternative bonds. For example, if it is single bond, here will come double bond. Single bond, here will come double bond. If it is single bond, it is having a negative charge over here. In double bond, nothing is there. First of all, you have to write it down. Now, if you are placing on both the ends CH3, it is referred to as what? Acetyl acetonato. Now, again, writing the same thing. Oxygen, carbon, CH, carbon, oxygen. Single, double, negative charge. Over here it is CH3, but over here now here comes out to be what? Your phenyl ring. Okay, so this is your benzyl acetonato. Is it clear? Is it clear? Now if I talk about the donor sites over here, very simple. If I talk about the donor sites over here, then it comes under the category of bidentate ligand. Is it clear? Over here, one more thing. This structure can be seen in like this form. See, if I talk over here, there is a resonance. This negative part can come over here. This can move. This can move over here. What will happen? This will move over here. So you can also see this structure as CH3C double bond O, single bond CH, double bond C, single bond O, negative CH3. It can be either represented like this, right? Kindly write and draw these structures so that we can move on to our next part. I guess you all have written this. Okay. Shall we proceed to the next part? These structures, until and unless you won't draw, you won't get it. Right? Right? Okay. Now comes dipyridyl. I'll write it over here only. Dipyridyl is very simple structure. See, what you have to do is, in benzene ring, you have to replace one atom with nitrogen like this. Okay. And then you have to connect it one more ring, again replace like this, one atom with nitrogen, right? So over here, two nitrogens are responsible for donating its lone pair of electrons. So it is again a category of bidentate ligand. Kindly write it down, my dear students. Now comes the next category, that is tridentate ligands. The third one is tridentate ligands. If I talk about tridentate ligands, again there will be 3 donor atoms present in the ligand. 3 donor atoms. Now see, in bidentate ligand you have done one example of EN, that is ethylene diamine, EN. Over here you will be doing the example of diene. In the previous you did only EN, now you will be doing diene. See again, what was EN? EN was NH2, CH2, CH2, NH2. Now over here you have to use it twice. Di referred to as 2. That means what will happen? CH2, CH2. Now over here NH2 will come. But yes, as I have told you, there are 2. So again CH2, CH2, NH2. Over here also NH2. That means we have written it twice. Now over here, how many donor atoms are there? This nitrogen is responsible to donate electron. This nitrogen is responsible to donate electron. This nitrogen is responsible to donate electron to the center metal atom. So there are 3 donor sites present over here. That's why it is referred to as what? Tridentate ligands. Is it clear to you? Is it's clear to you? Okay. Now your homework question, students. You have to draw structure for tetradentate. Draw structure for. I will be giving you its structure solution in the next lecture. Draw structure of triene, or I would say the tetradentate ligand. Is it clear to you, students? You have to draw this particular structure. You have to repeat the ene thrice. Right? Now, one more example is left, that is of hexadentate ligand. That is really very important and we shall be discussing it in next lecture. So, till then, your homework is to draw this structure. Other than this, you have to solve your questions given in your practice sheet or in your DPP. You have to try and you have to solve the questions. If you face any problem in any of the questions, student, you can write in the comment section. We shall be discussing in the upcoming lectures as well. Right? So students, in this particular session, what are the topics we have covered? We have basically covered the introduction. Then we covered the addition compounds, the double salt and the complex compound. Then we did the representation. And then the important terms with regard to NCERT, we have covered them. Right? So there is no need to now read NCERT also because I have already done that. Ligands and classification based upon denticity we have done, but yes, one is left, that is hexadentate. That is really very important and we shall be covering that in the next upcoming session. So students, I want you all to solve as many as questions that we have done. And one more thing, do revise whatsoever topic you study and in all the subjects you do in a particular day. Okay, revision is very very necessary. If you're not doing revision, kindly start it from today itself. Right? So we shall be meeting in the next lecture. Till then, keep smiling, keep learning. I hope so this session was easy for you and you were able to understand all the topics. So meet you in the next session. Okay, take care. Thank you. Bye bye.